Welcome to the Explainer. There's this hidden engine that powers so much of our digital world, and today we're going to break it down. It's called classification, and it's how machines learn to sort, categorize, and basically make sense of everything from your emails to medical scans. I mean, have you ever stopped to wonder, how does your email inbox just know what junk mail is and filter it out? Or how does your phone's camera instantly draw a little box around a person's face? Well, the answer to both of those questions is classification. All right, so here's how we're going to tackle this. First, we'll get into what classification actually is. Then we'll check out its three main types, or flavors. After that, we'll look at where it's hiding in plain sight in the tech you use every day. And finally, we'll take a quick peek under the hood to see how machines actually learn to do all this stuff. Okay, let's dive right in. First things first, what are we really talking about when we say classification? Let's get this core concept down. Okay, so at its heart, classification is what we call supervised learning. Now that might sound a little technical, but the idea is actually pretty simple. It just means we supervise the machine by showing it tons of examples that are already correctly labeled. The whole point is to get the machine to see the patterns so it can start categorizing brand new unseen things all by itself. And you know what? This is probably the best way to think about it. It's like giving a machine a multiple choice test. You're not asking for some new creative answer. You're giving it a fixed set of options, A, B, C, or D, and you're training it to pick the right one every single time. And it's really, really important to make a distinction here. Classification predicts a specific category. Is this email spam or not spam? That's different from its cousin in machine learning, regression. Regression is all about predicting a continuous number, like what the temperature will be tomorrow or the price of a house. So remember, categories versus numbers. That's the big difference. Okay, so we've got the basic idea down, but it turns out that not all sorting tasks are created equal. As the slide says, classification comes in a few different flavors. Let's start with the simplest one of all, binary classification. The name pretty much gives it away. Bi means two. This is a straightforward this or that choice between just two possible outcomes. And this shows just how simple it is. Your email is either spam or it's not spam. A transaction is either fraudulent or legitimate. And I love this food analogy here. It's like being asked a simple yes or no question. Do you want chips with that? Only two possible answers. Easy. But, of course, the world isn't always so black and white. What happens when there are more than two options? Well, that's where multi-class classification steps in. The machine has to pick one answer from a list of three or more possibilities. Now, the key thing here, the absolute deal breaker, is that these options are mutually exclusive. That means an image can be a cat, or a dog, or a bird, but it can't be all three at the same time. Sticking with our food analogy, this is like ordering a main course. You have to pick one, the steak, the fish, or the pasta. You only get one plate. And finally, we get to the most flexible and honestly, the most realistic type, multi-label classification. This is for all those times when one single thing can belong to many different categories at once. Think about tagging a movie, for example. A movie can totally be an action movie and a comedy at the same time, right? One item, multiple labels. The perfect food analogy for this one? Choosing pizza toppings. You're not stuck with just one. You can have pepperoni, mushrooms, both, or, hey, even none at all. The options aren't mutually exclusive, and this table just lays it all out perfectly. Binary, one choice from two options. Multi-class, one choice from three or more. And multi-label, you can pick 0, 1, or even many choices at the same time. It really all boils down to that last row, exclusivity. All right, enough with the theory. Let's bring this back to the real world, because I guarantee you're interacting with classification models way more often than you think, probably every single day. We've talked about this one a few times, and for good reason. It's the classic example of binary classification. Every single email you get is run through a model that asks that simple yes or no question, spam or ham, the good stuff. Have you ever left a review for a product or posted a comment online? Well, companies are using multi-class classification to automatically scan that text and figure out this sentiment. Is this review positive, negative, or just neutral? It helps them understand what customers are thinking on a massive scale. But it's not all about product reviews and spam. Classification is a huge deal in high-stakes areas like healthcare, Models can be trained on things like medical images to help classify a tumor as either benign or malignant, which can speed up a diagnosis and literally save lives. And how about keeping your money safe? The instant you swipe your credit card, a classification model gets to work. In milliseconds, it's analyzing that transaction to label it as either legitimate or potentially fraudulent, protecting you from theft before you even know it happened. So the big question is, how on earth does a machine actually learn to do all of this? Well, it's not magic, but it is a pretty cool process. Let's take a quick look under the hood. It really boils down to two main steps. First, you have data collection. This is where you gather a huge amount of labeled data. We're talking thousands, sometimes millions of examples where you already know the right answer. Then comes feature extraction. This is the clever part, where the machine learns to identify the important clues. So for a spam email, the features might be the sender's address, the use of certain words like free, or how many links are in the email. The model just learns which features point to which labels. And that's really the whole point of all this. The world is just filled with messy, unstructured data. And classification is one of the most powerful tools we have for teaching machines how to make sense of it all, to find the patterns, stick on some labels, and bring a little bit of order to all that chaos. And that kind of leaves us with a final thought to chew on. We've already gone from sorting emails to helping diagnose deadly diseases. So as this technology gets even smarter and more accurate, what are the next big sorting problems we're going to throw at it? What new questions will we ask our machines to answer for us?